Okay, so I need to cover two things today, multi-threading and NUMA tools, and then tomorrow is memory. And tomorrow's when we're going to get into TLB misses and start tracking those and talk about stride one and things of that sort. So I'd like to start off with an analysis of what's going on with Floyd 1. So I just want to start out with star 1 space 5. Okay, I got 100% user time, no system time. Star dash R 1 space 5. Only half my memory is being used. Very little buffers. 86 meg is nothing, raw I/O. And I got 22 gig of cache. We don't know what that cache field is yet. So I'm pretty much 50-50. And this is not node aware yet. I would also be interested in this from a node info point of view. Let me do a node info here, particularly in a CPU set situation. So there is one node that's kind of lightly loaded, and one that's a little bit heavier loaded. They're not evenly balanced. So this node 1 is running a little bit out of memory. This one's got extra memory. Again, I don't see any dirty data right now. I'd like to throw some dirty data at the system. I do see a slab issue here. I do have a 16 gig slab right now. Not pretty light on node 3. And again, each of these nodes is a socket and the processor attached to it. I'm going to get into PCP and look at this data in a PCP sense as well. So SAR-big S 1 space 5, just to look at swap. No swap allocated, nothing on swap. Swap's healthy. Memory doesn't, except for the slab, memory doesn't look too bad. I'm going to do a SAR-DP. I've only got 2 disks here. See if I can, I need to drop my font down here. Just so that I can get rid of that line wrap. Now if I do a SAR-D 1 space 5, you get it as a major minor number. You remember where you can map major minor numbers?
Yeah.
What's going on here? I don't know if it's me or the system. I'm not getting any response out of that putty right now. I'm going to also bring up my PM chart. I don't know what's going on here. I just lost that window. Huh. You're still able to see me, right?
Yes.
You're able to see my desktop. I'm just wondering if I lost a network connection somewhere. There's an instructor, Jim Martin, is kind of messing with DMZ-server. Let's see if I can go straight to Floyd 3. I can get to Floyd 3. Well, let me point my VNC viewer to that one right now. Let me try Floyd 1 first. Oh, that was the system with the problem. I don't want to do it that way. I was in there, and all of a sudden I lost my prompt. So I checked my network and could get to other things on the subnet. I think I was logged into DMZ server and then into Floyd, and I suspect the other instructor just did something on DMZ server to reboot it. PM chart -H on Floyd 1. I'm hoping I have a pre-built view. No, I don't. Okay, well, let's just do this quickly. Did I have it on Floyd? Let's see if, hang on here. SFT, can I ping Floyd 1 first? I suspect I can. I think I was just connected in through DMZ server. Yes. Oops. I'm just trying to avoid rebuilding everything. And there's the one I was looking for. Let me just get all of these. Remember, I basically created my own all-dat tab by adding in my own syntax in front of each tab that I want with a title for the tab. So let me do the PM chart again. There it is. And again, to me, these are two courses of an experiment or sample rate, 55. I only got about a minute, so I'm going to go down here and increase the number of samples. And to me, that's a lot better, and I got about 5 minutes worth of data. I'm also going to add another tab here. Let's call this one NUMA. And for this one, I want to look at the node info. Remember, I got to add this back into my tab description here. So mem, NUMA, util. Remember, this entire list that we have here is visible. I like to actually print it out, PM info-T, and I like to have a hard copy and print that thing so that I can see what all statistics are available, including things like luster, once you've got a luster PMDA running. Now, I can't, particularly in a large node count system, I can't build really a stack plot and make it useful. So I just kind of like to do a free, and there's my 4 nodes. I'm holding my shift key down to select the group and then adding it in there. Then I'm going to apply. And let me do that again now. And that was free, and then the other one I want is used. There's a mem info on a per node or per socket basis. And let me save that off. But again, I've not added it into the tab all directory yet, so let me take care of that. Well, let me just get rid of that again. I wish there was a way to save the view with all the tabs, but I haven't seen that available yet. There's my NUMA link. Get rid of these 2 things. Okay. And you can also hard code it where it actually has a host name in there. But I'm trying to use a generic display. And I've got the NUMA one as well. Now again, it didn't save my samples or anything like that. And again, I can't stack everything up on one. When I'm looking at all, this one only had CPU swap, memory, and IOPS. It didn't have file system space or anything like that. Let me add in a file system space and network traffic. File system and network traffic. I prefer bytes. And as you see now, that memory is real small and hard to use. Let me edit samples. And save view. I'm just going to save it onto all. And again, I can't see much in there, but being able to click to the other tab, I can now see that in more detail. And I can see the slab in there. Now, for whatever reason, something else is missing here. Let me see what I got here. Page table slab, dirty write back, unstable clean, buff mem, non-mapped, and free. I'm only seeing 90 gig in this chart right now. Oh, what's missing? Let me check here. Topology. Oops, if I can type today. Oh, wrong system. I want to be on Floyd 1. So there's 126 gig approximately. Again, you have to be careful about how these are being counted. I was having trouble getting through this. Let me do a more on /proc/mem-info. So here it's showing 132 gig. Don't worry about them not balancing. Some are powers of 2, some are powers of 10, how things are rounded, things like that. We got here 61 gig of free. Free is, let's get rid of all this stuff. Trying to figure out why it's not showing. So 61 gig of free is showing up there. Buffers was raw IO going through /dev, and that's 86 meg. Let me get rid of free. I'm just trying to figure out where my memory is going. Let me get rid of that. There's 80 meg of buff mem right there. My cached here is showing up as 5.6 gig. I don't have cached visible in the chart. I have taken cached and subtracted from it. So I don't really have cache showing up in here, and that might be part of my problem. Let's see, dirty is small, write back is small, mapped is small. My slab, how big is my slab? 16 gig. Let's see. There's my 16 gig slab. My anon was 400 meg. Anon is my process space. Yep, that's about right. Very small on Shemem. So there's something else going on here I'm going to have to worry about later. And what I'm complaining about is when I look at this whole map, I've only got 90 gig visible here, and there's 30 gig that's not being counted for some reason. Don't know why right now. Cache clean. I'm going to try another thing here. Let me do a new add tab. I should probably change the title of the tab. I know there was a way to change it. Edit tab. Open view. And there is a memory view here pre-built, but it doesn't break out memory very well. So here I've got other. Other is basically anything that isn't cache. That one's coming out right. So my cache field there is okay, other, and then free. So I'm going to have to come back to this later. Don't know why I'm missing 30 gig on this chart. Let's move on. I got into that because I started getting a performance event, and now I've got this stuff available to me if I need to. In fact, let me start a recorder here. Again, we have PM Logger running on that system too, but that's in 10-minute intervals. So I don't know where I'm missing memory, but I'm just going to have to come back to that later. Now, I've been talking for a while, so let me see if I'm still in the same situation. So again, my CPUs, let me drop my font down again. Keep in mind as you're looking, things change, and that's why I can go back to the PM chart and see if anything has changed. So SAR 1-5. My screen, 100%, but that doesn't mean that's productive work. We don't know if that's good work or bad work yet. No system time. I don't see anything. I'm sorry?
I do not see anything here now.
Oh, you mean you're not seeing my desktop?
No, my screen is blank.
Anything else? I went back to my presentation. Anything catch up to you yet?
Okay, yep. Try again.
Let me try going back to my desktop.
Yep, I see it now. Good.
Okay, yeah, just jump in at any time. I don't know what that was. It must have been a network catch-up. You'd mentioned some sluggishness on PM chart. Must be something on your network connection that's a little sluggish. Anything else right now?
Good, I'm good.
So all I'm saying is my CPUs are 100% busy, but that doesn't mean I'm getting productive work done. Nice. Something is running under nice. It could be that cron event from the locate utility and find. We don't know yet. A little bit of system time, no IO wait. Steel was for virtualization. I'm going to do a SAR-Q 1-5. So I've got this is not good here. With topology, I've got a 32 CPU system, but I'm seeing 65 processes on the run queue. That means my processes are only getting 50% of the CPU. And my load average has been 65 for the last 15 minutes. Let me do a SAR-Q, pipe it into more, and it's been at 65. Oh, look at here. It was even up in the 120s and stuff like that. And then it stabilized to 65 about 1:20 in the morning. Let me go into var log SA. I'm trying to get a baseline right now. -Q, type into more. So midnight, let's see. There's a reboot. about 11 o'clock last night, my load level went up, and then it looks like it started falling and stabilizing just before midnight. Again, I have that SPV tool or ISAG. I want to get a baseline here. People are always asking what's a good number, what's a bad number. I need to see a big picture. If I could see a month's worth of data to see what's going on, that would be real nice. And that's what the advantage of ganglia, for example. Desktop's having a little trouble getting things when my load level is more than the number of CPUs. While that's happening, *W 1-5. That is context switching. These are the number of processes forked per second, and then this is number of processes that are switched on the CPU. So we talk about context switching. These are the number of processes. These are processes that get connected and deconnected from the CPU, saving the state. The state includes the program counter and the internal registers. Notice my desktop is having trouble getting running, but interactively, I've got decent response. I can do things interactive fine. I'm going to bring up top. So here's what I was looking at, 65 running, 65 load level, but I've only got a 32 CPU system, nothing stopped, no zombies, 100% CPU utilization. We've seen all that. Here's my memory, 129 gig. 69 gig is being used, 59 gig is free, 22 gig is in cached, which includes the slab, remember. We didn't really look at the slab yet. Also remember now, on a large CPU system, top isn't going to see the whole thing. And my desktop's still having trouble getting running. Then here's the other system with PM. PM chart is able to get in there. Oh, I did see some sort of I/O activity drop off here. But we've got some sort of reads going on disk. So these code 6s, I don't know if they're good or bad. And I've already done a Shift W, looks like. Oops. It was not able, that VNC viewer was not able to get into the system. Timed out. Nothing on swap. All swaps free. We were pulling that apart. Let's get out of here. More on /proc/meminfo. Shows that the cache was only 8 gig. But remember, things like free, SAR, and top are adding slab into it. So I got 16 gig there. And that 8 plus 16 is where I'm getting to the 22.
Okay.
Okay, so since I have a large slab, let's do a slab top -S space C. And I see that my slab is mostly metadata. And again, this is the same problem we had before. Buffer head is a buffer header chain for things like dev shamam, for raw I/O, things of that sort. Okay. SAR-DP 1-5. We looked at CPU memory. Now I'm looking at disk. So I can see SDB is busy. In fact, SDB was not too bad, 22% busy. And I like these to be less than 80. These are in milliseconds. And I like this less than 30. So that's borderline. I'm going to do a top disk. And I can see the drive is pretty consistent at 23% busy with reads occurring 8 KB reads. Not very efficient. I'd rather have things in a larger chunk size. Now I'm just curious. I'm going to do an IO top. And there it is. The find command is running. by doing fuser-uvm on, oh, we don't know what SDB is yet. VF, SDB is data 2. By the way, look at data 2 is 100% full, and with the DF-I, don't forget about that one, it's also 100% full. But we're not writing to it, we're only reading to it. Let's try it. Touch. That worked? Huh. I wasn't expecting that to work because there's no inode space out there. Huh. There they are. The only thing that was running there is the find command. ps-ef, grep for find. Now this is that cron event for the locate utility. Let's do a ps tree. Unfortunately, Putty's not going to like some of the characters, but here I can see find as a child of update DB. And update DB was a child of cron. And that's what that, when we're in top, again, I didn't see any of this thing, but that's what this nice here was. By the way, watch this. I'm going to bring up top and look at the crap up here. Now it's stabilized. You cannot trust the first sample of top.
Okay.
And some people will do a top-B. -N for number of samples, do a 1. And you cannot trust the data that's visible there because you don't get a confidence interval. You haven't gotten a clean sample yet. That's why I use PS. But top is giving me a CPU number. If I do a PS-EL, my CPU, oh, hang on. We'll get into this tomorrow. I need to change my PS report. I wish this was the default. So with PS, I get the CPU number, but if it's not running at the time, if it's in a sleep state, we get an asterisk instead of the last CPU that it was on. So this is one of my gotchas where I wish that the Linux developers would resolve this, because I want to be able to see CPU numbers here, because I can't use top with one sample. I have to do a couple of samples, and then it's hard to filter out that sample so that I can get just a single line for each process. You okay with what I'm saying?
Yeah.
So ps-EFL, grep for find. There's the find. And I'm going to do a strace-p on 25928. Oh, that's the wrong one. That's the parent. It's sitting there sleeping, waiting in the system call. It was 25929. Grabbed the wrong one here. This one. And now I can see, oh, wow, it is writing the standard out. That's the stuff that's going to get sorted and put in the database. I am seeing a permission denied here, but we're basically in the data 2 file system here. I can't really tell these opens. I didn't see the actual path that it opened into. So it looks like that thing is basically just going out there and looking at the inodes. That's what's causing the slab to grow. In older releases, access times were not really being tracked on a directory basis. Now they are. This results in access time and the metadata changing, which results in the journal being changed, and also the metadata being loaded into memory and then written back out and flushed later. There is a *V that will tell me how many objects I have in memory. So again, SlabTop was telling me stuff, but I've got 5 million directories and 5 million inodes in memory right now. And SDB has 137 million inodes out there. Now there is a sysctl-a grep slab. And by default, my kernel can only grow to 5% of my memory. So let's see, we've got a 128, 12, must be about 6 gig that would be the ceiling for the kernel. Let's grep slab on proc mem info. And I'm already over that at 16 gig. I've been complaining about that. That ratio doesn't seem to be, it does have an effect, but I am growing larger than what the slab ratio says. I don't like to see these slabs get huge, particularly if it's metadata in a case where somebody's got a find command running and there's an NFS mounted file system that has millions of inodes in it. Any questions right now?
But the 5% it's only minimum. It's not a maximum.
No, not really. You can take a look at it. It will keep the kernel down. I agree with what you're saying in terms of description, but in terms of adjusting the behavior, and I've been complaining to Hetty about this. But when I try to get a large kernel, I can up that. Let's see. Let's see what it says here. Let me just go here. There's a website that kind of helps document this stuff. Proxys hierarchy is what I was looking for. Let me go to the VM group. And slab ratio. Percentage of total pages in each zone. On zone reclaim, slabs will be reclaimed if there's more than this percentage. This ensures that the slab growth stays under control. Okay?
Okay.
So I'm just going based upon pounding it. And again, the main command I'm doing to create all this metadata noise is postmark, which is a benchmark tool out on the web meant to create emulate email spam attacks without the network load behind them. Things like varspool news, varspool mail, that sort of thing. So I'm just going to get rid of that thing. Let's go back to my desktop here. I can now see that that find has stopped. I just wanted to quiet it down right now. I don't really care about what it was doing. Again, I am recording all of the PCP data as well. Well, anyway, so my disk activity has stopped there now. Let me go to the mem chart. There's my slab. Slab top dash S space C. Still XFS data up there. Now there are two different ways of doing this, sysctl-w, and I'm going to set the vm.drop_caches. BC-free will also call this. BC-free is a command that SGI puts out that's on top of this, and BC-free will also do syncs and a few other things. So I'm going to set the drop cache as a 1 says for page cache, 2 says for slab, 3 says for both. So here's the question now, how long is it going to take to trim that slab? Okay, we start dropping data. I got some of my cache back, by the way. Let's see, where's the cache clean? So there, I trimmed the cache clean, and now I'm starting to see the slab trim. Again, there is a bug in this area. Hetty, looking at it earlier in the week, there's an XFS bug in this trim area. I'm not sure how quickly that will trim right now. So I got 11:26 here. Let's just see how long it takes for that to happen. Okay?
Okay.
So I'm going to move on with my analysis. So I've looked at CPU. I've been looking at memory. There was nothing out on swap. What's next? File system, buffer cache. We've looked at those. Then inter-process communication. So let's see what we got going on there. I'm just going to pop back here every now and then. You can see the slab is slowly trimming. Do we have disk activity going on? Not a whole lot of disk activity. There are some writes in there. Question is whether any of that inode metadata that's in memory has to get flushed out to disk. So if we've modified access times and stuff and it's in memory, then we got to sync it out to disk again. So CPU was 100% busy. By the way, let's see now with top, or SAR even. That nice is now gone because I got rid of that find cron event. Okay? We didn't actually look at the nice value when we were in PS. We do still have some system time out there. I'm going to do a top sys. That's an SGI tool. This is bothering me on these latest kernels. The migration threads, I've been driving the migration threads crazy. Look at how much time they had. And again, with TopSys, this is delta, so we're waiting for a sample, waiting for a sample. Just got a sample. Waiting, waiting, waiting. Just got a sample. So that is the amount of time that that process was in the kernel during that sample. And then this is the amount of time it's in the kernel since the process started. Okay? I am going to do something else here, perf top. And again, I've got that Intel idle still showing up. Not going to worry about that. Clock interrupts. And these are all my system time. Am I on the right system? No, I'm not. Sorry. My mistake. Oops. Try that again. SAR 1 space 5. My nice is still gone, as I was saying, and I was trying to look at the system time. I was on the wrong system, though. Okay, so there's a little flush going on there. Here's PCP. Remember, there's the sort that's taking that find data. I never killed everything. I need to look at K-worker threads a little bit more. These are handling the top-level interrupts as I know it. If you've got a good description for a K worker, go ahead and send it to me in email. Oh, we got an MPI run in there. This is part of PBS. There's a flush going on. I was just seeing if the journaling activity was in there at all. I don't see anything in there. The other day we had XFS AIL, action item list for metadata, or XFS log types of daemons. Okay. See if I'm still in the same situation right now. Again, I can't take this first sample, but there is an occasional nice coming in there. Remember, we still have that sort going on. I just want to get that noise out of the way for analysis purposes. And yeah, I'm being a little reckless, but I don't really care here. So that nice noise is gone now. The system time is what we were looking at. So now we were back at perf top to look at that. Again, that is real small system time. I could care less. And, oh, I'm seeing something different here now on this system. I see an MPI application running. Oh, I see the global reference unit being used. And then underneath that, that system time is this stuff here. This native write MSR safe, scheduler ticks, update the load levels and stuff like that. And this is the one that I'm trying to dig into in more detail, spin locks in the kernel. So I'm seeing something different here now. Let me get out of there because I never finished. I was pulling apart that system time. So I pulled apart the user time, and I see MPI for all that user time. And by the way, this is barrier synchronization. This is inter-process communication in MPT. My application is stuck. It's not doing anything. It is spinning on a barrier. That 100% CPU utilization is getting no work done. I'll demonstrate that later after a break. We're going to go OpenMP and then MPI. So I looked at CPU, I looked at memory, no swap. I've looked at disks. Let's see what the disks look like now. I wonder now that the find is gone, how's that slab trim going? So my slab is finally finished. 11/28. I forget how far back it was when we did it, but I have CSA accounting on. Disks are quiet. Let's do a CSA com-n on sysctl. That took 190 seconds for that trim to occur. That's a 16 gig slab, all of it metadata. I'll do something else here. Let's do a -w. And it was waiting 130 seconds in there too on a CPU, it looks like. I don't see any I/O wait. It had 63 seconds of CPU time. Let's split that out into system time. You can see how useful for me CSA is. So system time, it was all system time, 63 seconds, 190 seconds of elapsed or wall clock time, and 130 seconds waiting for a CPU. And remember, it had to compete with these other codes that were running. When I bring up top, we had these code 603s. You okay? Look at how long they've been running. So, CPU, memory, disk, file system, that's what we just cleaned up just to get the noise out of the way. Buffers, no real buffers. Look at the buffers are down to nothing because I did a trim. I trimmed the slab. Let's do a slab top -S-C. And notice all my metadata and stuff like that is way down on the list. I always do it by S-C. I wish that was the default because I want to see it by memory footprint. Here's the process table. And again, these were saying if the kernel needs a 2K by by structure, rather than intermixing large, small, and fragmenting the slab, it will go to a size table for saying, I need 1K, just put me into a 1K area. That way I don't intermix small and large and get into a fragmented slab. So CPU, memory, disk, file system, buffer, cache, interprocess communication. So let's do an ls-l /dev/shmem. Nothing there. IPCS-am. We have a little bit there, but nothing big. 3-4 meg. Let me grep shmem/proc/meminfo.
Right at 39 meg.
Yeah. And rounding and stuff like that is putting that at 27. I always say if I'm an accountant, I'm like Arthur Anderson, the old accounting firm. I don't care if the books don't balance. I just got to rough it together, but you're going to see differences here, just like we had with the more/proc/meminfo. That one's showing 132. Topology showed something different because it was rounding, and sometimes it's powers of 2 versus powers of 10. So that 132 showing as 126 here. Then if I do node info, that's showing 134 there. Okay? Now, I want to do one other thing for you while we're looking at this. I am going to go to KDB. How would I go to KDB here? You've used KDB, I'm sure, right?
Yes.
So how do I get to KDB?
The console.
And where do I get the console?
PMC.
Great. Oops, I got to go in as root. So UVCon, I don't want to see anything. I may want to keep what's ever on the console, but I may not want to see it right now. A clear will clear it the next time I connect. But I may have something on the console like a panic message or something that I want to be able to see. So I'm just going to do a no cache, which simply says don't print it out when I connect. And I was bad. I came out of the console yesterday without logging out. So what do I do to get to KDB now on the console?
Okay. It's KDB.
Uppercase KDB. Okay? And a summary command will give me my meminfo. However, I have a long-standing RFE because they don't have shmem in here. Shmem is missing, and I wish it was in there. Because if I have a shared memory leak, I can't tell from here. I might be in an out-of-memory killer situation. I might be able to go in, and the system seems hung. I might be able to go into KDB and clean up shmem, for example. I have gone into KDB and killed large processes, but that doesn't clean up their shared memory. And by the way, right now, my system should be in a paused, checkpointed state. I don't like being in KDB too long because I can get a timeout. I'm going to get out of here for a second, control right bracket Q, exit, and this time I'm going to go in, type TEE, and I'm just going to call it a Arch KDB output. Usually I put a date on it. And now I'm going to do an Arch KDB. But this can be a little bit dangerous. I have very rarely, but I have occasionally had PCI timeouts, for example. Now, what can I do to get this information? So I'm going to type in a go now. What can I do to get that information without going into KDB? Did I get back here? I am back. So how can I get that information without going into KDB? I'm going to echo a T into /proc sysrq -trigger.
Okay.
So if I'm in a production environment and something's going on and I want to be able to look at those stack traces, I don't like dropping into crash and looking at each individual process to look at their stack traces. So I'm just going to echo a T in there. And it will take a little bit.
Going to T stage.
Question?
The information will go into a D message or go into message.
So D message is reading the ring buffer out of the kernel for the printfs.
Okay.
Syslog reads it out of D message and then puts it into var log messages with a timestamp on it. Sometimes, like yesterday, syslog had crashed earlier in the week from Unkiller, but it was still in D message. But I have had cases like in killer events where things are not in D message because they seg faulted instead of got a kill. And here now, there is another file that I use quite a bit, /proc/debug_info. Sched debug, I'm sorry. Sched_debug, and you also get this on a per process basis. And in there, for example, we can see what's running on a particular CPU. I wish I actually had some way of, I wish there was a tool to pull apart this data. I wish I could actually see this stuff and grep through it on a 4096 CPU system, trying to get this, basically the run queue on a per CPU basis. I don't know of an easy way to pull that apart. Okay? So let me just go into var log messages now, because that is now dumped out with a that echo T. Echo T will put it in there, and that's extremely useful information now. So I can see every one of my CPUs has 2 code 603s running on it, and I can see all the run queues on a per CPU basis. And when I'm trying to get into affinity and privatizing, I've got noise here from other things, and I don't want that. And then I was trying to go back. Imagine working in a 4096 CPU system. This stuff just gets too noisy. Okay, now I'm into the tracebacks. And I was kind of looking for like, oh, here we are. Looks like there's something funny with KDB here. At least, I'll double check, but at least with the echo T. So here's a code 603. It's running, but for whatever reason, the traceback is giving me some weird multiple lines. So this code 603 had dropped into the kernel, had some sort of timer interrupt going on, and I can't completely trust this traceback right now. And then GRU is being used for, this is what was called the MOE, the Mpi Offload Engine. This is inter-process communication between threads. And it's actually looking like it's resulting in a switch to the CPU scheduler. Okay? I'm not sure I like that. Let me just get out of here. Oh, no, I wanted to go to this one. I just want to see if the Arch KDB was any better. So these things are running. And I'm not getting any sort of, in this example, getting any sort of traceback because they're not in a sleep state compared to the one that I was looking at there before that was. You'd only see a kernel stack trace when it's sleeping. There's init. Let's see if I can find anything on the GRU. I can't. So I was just trying to see. The Echo T seems to be giving me a little bit different report than what I'm getting from an Echo-T. Okay. I'm going to do something else here now. Oops. Now, if I do a module load Intel, oh, I forget what we called it here, module avail, module load Intel-12.1. And then let me try running. I've got a /code2mp. This is where we're going next. And notice that it's complaining that libI Intel OpenMP library is not being found. So I've got a problem with my library path. I don't want to fix it for you, but sw/Intel module files. So you're going to have to fix this and go in and take a look at what's going on with these paths. Actually, this is the one, oh, these are commented out. So bin was working, the path was working, but for whatever reason, it's still having problems here. Now, what I would normally do is take a look at the PS script that's out there. So I'm going to do a source/SW Intel, what did we have there? Bin, and in there is a iforts.sh. I'm going to run this and it's going to complain, oops, because it now needs an argument passed into it in terms of what architecture it is. Now let me see, echo $path. So it's putting this path, okay, it's loading that path. You following me? Now what was the other one? The libraries are the ones we were interested in. So let me echo library under path. And notice it's got a lib Intel 64 in there. I'm just going to execute that thing. I've already done it actually, but you're going to want to fix your module file so that you've got that lib Intel 64 in the path. You following me okay? You okay, Jay?
Yeah.
So what I'll often do is simply find the PS environment scripts that come with the package, load them, and I had to do this. Then by echoing my path and my library path, I can see what it was doing. Or I might actually look at the script to see what environment variables it's setting, like manpath and stuff like that. So let me do a ifort-03. I'm going to do a dash parallel. Again, the rule in this class is we can't change any source code. This class is for administrators to analyze and look at data, not for programmers. So in a benchmark situation, I can't change source code.
Yep.
Let's compile that thing. Oops. My recording stopped for some reason. So again, I still have CPUs 100% busy. Swap is okay, memory is okay, disks are okay, interprocessor communication was okay. I'm purely CPU bound. Let's see if VNC Viewer will work right now. Looks like VNC Viewer is still having trouble getting in there with the contention from those code 2 MPs. And I'm trying to compile as well. 100% busy. Well, interactively, I was fine. The desktop isn't. I don't know about code 603, whether it's good or bad. Some applications will have statistics written out from them that are in a time-step concept. And then they'll say, oh, this next phase of my application is not performing as well. So we are competing with everything else. Waiting for that compilation to finish. I'm not able to get my desktop on that system yet. There, compilation is done. Let me do a CSA com tail. And look at the Fortran, oh, that's memory, I believe. So it took about 76 seconds for that thing to run, elapsed time. Let me do it with a -W. And it looks like 51 seconds with CPU wait time there. Let me just confirm that. So that's my CPU wait time column. And it waited 51 seconds for a CPU. That's why I like CSA data. And post-mortem. Get delays while it's running would be handy. Let me try get delays -D -P $$ and look at myself. Oops. What went wrong here? Invalid PID. Oh, I don't know what's going on there. D for delay time, P for print, actually.
It's PID, right?
Yeah, I'm not sure what's going on here. Let's try one on one of the code 2 MPs. Or code 6, I mean. 20348. Huh. Not going to worry about that right now. It was working yesterday for some reason, but there's something funny going on right now. The man pages on this aren't exactly working right. D was to print the delay statistics, and then P for the PID. The listen forever doesn't really work. That's why I usually do a watch. Maybe because, get delays, I'm guess, not root. Maybe that's the difference. I'm used to using it as root. I bet that's the issue. I can't connect to that socket. TaskStats is a socket connection, basically. So now let's try it on that on that code 603. There we are, and you can see the amount of CPU wait time that thing has had. I believe these are in nanoseconds. That's something that you could, if you ever get time, I need to figure out what unices are and how to get them into seconds in my program, or the task logger that I was showing you yesterday. I believe these are in nanoseconds. But I wanted to get it into seconds. And that task logger command is just printing out in this unit here, and then when I tried to get it into seconds, I was just getting garbage. I want my CPU times and my wait times in seconds, not in whatever unit this is. I've assumed it was nanoseconds. And then you get a raw count too, but I don't care about the count. That doesn't matter to me. I just want to be human friendly. Just wrapping up here now. Let me get out of here. So I was going to run this code 2 MP. multi-threaded. Then we'll take a break. Let me break out of there for a second. I want to put it under time. Be nice if time could get to the delay statistics too, but it can't. CPU wait, memory wait, I/O wait, bytes transferred, number of system calls, context switches, major minor page faults. That's all useful information. And I know Scott Emery and Ken Taylor are big fans of CSA as well, but disadvantage of it is in a cluster situation. But it gives me accountability. Accounting isn't just for billing purposes. I can go back and see. That's the problem I have with this one site. They're saying it takes 4 hours one time, 8 hours another time. And I want to know if that is user time change, system time variance, trim weight variance, I/O weight variance. I just know one time is 4 hours and the other time is 8 hours, and they can't give me the 8-hour elapsed time components. They can't break it out for me. And they're not willing to put CSA on their system, and it's inside a firewall and everything. So, Code 2MP appears to be running. Remember, we were in the 9-10 second range before, but we do have to compete with other things. Let's see what we got going here. So I'm still 100% CPU time. Memory and I/O is all healthy. Let me go to Floyd 1 again and poke at this. So I can see Code 2MP running in here. It's at the top of the list because it's sorted by percent CPU. Now, we haven't talked about this yet. Percent CPU is what I like to call the hog factor. This is saying what percentage of the last time sample was I connected to the CPU. Okay? If it's greater than 100%, that indicates it's p-threaded. So to see the p-threads, I'm going to do an H option. And now I can see each of the individual threads. And I can see each of these threads, oh, they're gone now. Why are they gone? Because code 6 is now dominating, because we're sorting by this. And now I can't see the code 2MPs because I don't have enough lines here. Let me do a Shift capital W to save this in thread mode. Now let me do a top-B-N. I need 2 samples at least to get a confidence interval. And then I'm going to put that into a file. Let me look at that file. Again, I can't take the first sample. It's not useful to me. There's the second sample now. So there's a code 2MP, and these things were down in the 31% CPU utilization. And again, it's connected to the CPU, using the CPU 31% of the time. Also want to try something else here. Let me do this. Oh, this is not the system I wanted. Hang on. So that code 2MP is still running. Let's see if I can get a PID for it. I actually need to use a -T to see the individual threads. OpenMP calls p-threads, so OpenMP and p-threads will have an individual record for each thread when you use the -T. By the way, I'm going to go into /proc/264 7, 8, which is the master thread, and go into the task directory here, and I got a directory for each of the threads. I got 33 threads running. One is a shepherd, and the other 32 are my workers. By default, Intel is going to look at the number of CPUs on your system to determine how many threads are going on. I need to warn you about this, Jay. The latest Intel 12 compiler changed its behavior. In prior releases, the Intel library looked at the number of CPUs in the CPU set, not on the system. So if I was on 4 CPUs in a CPU set and on a 4096 CPU system, it's going to spawn off 4096 threads. And if I'm on 4 threads or 4 CPUs, I'm in trouble. You can't use dplace anymore. You got to be using OMPlace. And OMPlace will explicitly set the number of threads to what's in the CPU set, not the number of threads to what's on the system. So I want to do a bad thing here. I'm going to export OMP_num_threads equals, I'm going to go 512 threads wide. I didn't want to do it here. Wrong window. I need to do it as a user. That code 2MP is still running, by the way. I want to do a top sys, see if I got any system time with it. Remember that code 2MP was in 9-second range. Nope, no real system time. That's fine. So I'm going to break out of there. It had already been running 6 minutes, and we were in the 9-second range with the single-threaded version of it. So this is where we're going next, and I'm kind of doing a demo, and then we'll take a break here. So now I'm going to do an export OMP_num_threads equals 512. I'm just picking a really big number here. Now let's try running the code 2MP. And now I've got a new problem. Look at my system time. You know what that system time's from? I should have gone another display here. Add tab. This happens all the time at sites. I've had sites where they submit an MPI job. It's 64 CPU system, so they do a -NP64. But they've linked in an OpenMP library, like the old SCSL OpenMP libraries. And then that library will spawn off 60 more threads, and now they've got 64 times 64 threads on a 64 CPU system. That will not be good. So I get to the site and see high system time. Okay?
Yep.
I was going to go to this one.
Okay.
And a new chart. We're going to get a break here real quick. I appreciate you bearing with me. I'm hoping this is useful for you. It's just hard for me to find a good break time. I want to go to process switching here. It looks like I got 2 million contact switches per second. If I do a SAR-W, I was in the 2,000 second range. SAR-W 1-5. Now I'm in the 2 million range. Still with me?
Yep.
So if I bring up top, I'm going to get rid of the per thread stuff, get threads off. There's my code 2MP. There's my 40% system time right now. Okay? So how do I look at system time? How do I pull that apart? Let me start off with a top sys. code to MP. So all that system time we're seeing is from this code to MP. What next? What can I do to look at that system time in more detail to find out what the reason for that system time is? Perf top. Now, what was that system time? Thread return, CPU scheduler. Here we are, the application, KMP wait yield. There's a raw spin lock in there. This clock scheduler, previous fair task, KMP yield, switch to. Remember, I am now thrashing on context switches, all driven by a sched yield. Now, it will depend upon your kernel in terms of what it looks like, but that context switching is all, or that system time is all context switching. Okay, so I have overcommitted the machine on purpose. This code to MP is thrashing on a barrier in sched yield. I'm just curious here now. PS-ET, let's rep for code to MP. Let's do a GDB to pick one of them. And they got to have CPU time associated with them. There's one shepherd there that isn't doing anything. I don't know, it looks like I attached to the parent. Let me do a BT. So it was in CLint. And then from there, we are in a KMP join barrier. So within CLint, it hit a routine that is OpenMP, and that barrier is stuck. We are stuck on a barrier. You following me?
Yeah.
If I do an strace-p, let's try 26646. Here's what the thing is doing. Sched yields. Oops. I don't know what happened there. strace kind of writes to standard error instead of standard out, so I can't really redirect it. But the other thing that's going on in here is a futex wait. Let's see if we can catch that. If I go into top, go into H, no, I wanted threads on. Oh, still can't find code to MP because it's buried in there. We do a PS-EL and grep for code to MP. It is in a futex wait. So this is where we're going. That code to MP, we were 9 seconds in CLint. But now if I profile it, I'm going to be in the kernel and in the MPI library, or OpenMP library, doing barrier synchronization, doing that P-thread join. Now, I describe this as playing phone tag. So my threads are sitting there, are you done, are you done, are you done? That's the futex. And Intel MPI does the same thing. So the futex is a user synchronization flag, and it's sitting there, it's going, are you done, are you done, are you done? If not, it does a sched yield to give up the CPU to somebody else. But in my opinion, sched yield is not working correctly. It's going to be looked at in the next week. But I've had probably 3-4 years on this bug. Look at my context switching right now. Look at my system time. Now I'm going to do something. Then we'll take a break. sysctl-a, grep for compat. I'm going to set this kernel.sched underscore compat underscore yield to a 1. In other words, use the older sched yield. time just went away. My sked yields are now behaving correctly. I still have barrier synchronization problems, but now I'm yielding to the code 2 MP or code 6s. But the code 6s are also stuck on a barrier. But SGI's MPT does spin barriers, whereas Intel's OpenMP and Intel's Mpi does yield type of barriers. I'm going to kill off that code 2MP. I'm sorry, code 603. Let me bring up top. So now I'm all seeing code 2MPs, and I can see the futex weight is the synchronization. And Intel's not using the GRU, unlike the SGI's MPT that was using the GRU, the MOE, the Mpi Offload Engine for synchronization. So here, this is saying, I'm checking with the other threads. Are you done? Are you done? Are you done? And if not, it's sked yields. Let me do an strace on one of those things. 26684 looks good. And there it is. Sked yield, futex, sked yield, futex. SAR-W, 1 space 5. I'm at 2 million context switches per second. To go back to here, look at what my system time is now because it's thrashing on itself now. The code 6s are no longer there to yield to. So these threads are yielding to the kernel, and the kernel's throwing it right back to the thread, and then the threads are doing the sked yield again. We are thrashing on a sked yield. This is all non-productive CPU utilization. And in both cases, I was fine interactively. It was not impacting me interactive. But these applications were stuck. They are not getting their work done. The code 6 has been running since last night. Okay?
Okay.
Now, while that thing's running, remember, let's get out of here. Where's the other? Oh, doggone it. Got to be careful. I'm coming in through DMZ server. Let me SU to guest. So I have a multi-threaded version of the thing that I just compiled. I added a dash parallel to create that one. Now I've still got the older one, this one here. Let's do a time, /code 2 GNU 03. Can't really see it much. It's buried in the noise there. By the way, I can correlate here. This is when I adjusted sked compat yield. It had somebody to switch to, but here it doesn't. I'm still in the older compat. By the way, that's finished. It came in at 22 seconds. Let's do a CSA com-n code 2 GNU 03 -w. I spelled it wrong. There's the one we just ran, 22 seconds. No CPU wait time for it. It was able to get through because of those sked yields. There was no contention for it. So the multi-threaded version is still running, and the single-threaded version was able to get through in 22 seconds. I'm going to take a break now. Do you have any questions?
No.
Okay, let's come back at 1:30, and then I'm going to start the next lecture.
Okay.
So we'll see you in about 15.